Something else I wanted to go over, just again as a refresher and to clean a few things up as far as chemical formulas. So when we're given a chemical formula, if we're given the molecular formula of something like H2O, that means that if you have a glass of water, the chemical formula for each molecule is 2 hydrogens to 1 oxygen. Now, sometimes when we're looking at a chemical formula, what we realize is that the ratio of atoms is not the lowest common denominator. Now, that is not a bad thing when you're talking about molecular formulas. In other words, if I have, we'll see in this case, 7 carbons to 14 carbons, well, the lowest common denominator, I can divide each by 7. But that doesn't mean in the real world the molecule exists as 1 carbon and 2 hydrogens. The molecular formula is the true formula, the true composition of a molecule. However, when we do chemical analysis, we often find that instead of getting the molecular formula, we end up getting the empirical formula. And the empirical formula is the lowest whole number ratio of a set of elements in a molecule. Now, in the case of H2O, in the case of water, well, the empirical formula and molecular formula are the same. You can't have a fraction of an atom in a molecule. So if I, divided this by 2, I would have, half an atom of oxygen. So that doesn't make any sense. But for C7H14, if I divide everything through by 7, again, finding the lowest common denominator, this gives me CH2, right? 1 carbon to 2 hydrogens. This would be the true formula, the molecular formula of this compound. However, if I did a chemical analysis, so I did elemental analysis where I burn this carbon and I get the ratio of carbon to hydrogen, this is what my data would give me. Now, what I need to go from here to there is the molar mass. And we did an example using molar empirical formula and molar mass in class, and I'll generate some more problems like that. P4O10, so in this case, we can divide by 2, so we can get P2O5. Again, I can't have a fractional atom, so I can't clear the phosphorus to a 1 because then I would have a fractional value for oxygen. So again, don't think that your empirical formula always has to be a ratio of like 1 to something else when you divide through. It's basically whatever that lowest common denominator is. H2O2. Now, notice I've got H2O here and H2O2 here. This is the chemical formula for water. This is the molecular formula for water. This is the molecular formula for hydrogen peroxide. So this compound exists. You can find it in your medicine cabinet. In other words, it's in that amber bottle, hydrogen peroxide. But its empirical formula is going to be a 1-to-1 ratio of hydrogen to oxygen. So this is a case where we have the true molecular structure, H2O2, but if you were to do a chemical analysis, you would come up with a 1 hydrogen to 1 oxygen ratio.